In this module, we turn your PKI from theory into practice. You'll issue a TLS certificate from ADCS, bind it to an IIS site, and confirm that internal users get a clean, trusted HTTPS experience in their browsers. No warnings, just secure access. You've already built a full PKI stack. You understand the theory, you designed the lab, and you deployed ADCS with working templates, enrollment, CRL, and AIA. Now we move from building the infrastructure to actually consuming it, starting with securing an IIS website using HTTPS. IIS often hosts critical internal apps and APIs that handle sensitive data. TLS protects that traffic by encrypting it, proving the server's identity, and preventing tampering in transit. However, many internal sites use private DNS names that public certificate authorities won't issue certificates for. This is where ADCS fits in. It lets you issue certificates that your domain-joined devices automatically trust, eliminating browser warnings and giving users confidence their connection is genuinely secure. For IIS over HTTPS, keep 4 quick checks in mind. First, the certificate's subject alternative name must match the site's DNS name. Otherwise, you'll get name mismatch warnings. Second, it needs the server authentication EKU, so clients know it's allowed to identify a server. Third, IIS must actually have the certificate's private key, or it can't complete the TLS handshake. Finally, clients must trust the issuing CA chain, or they'll flag the connection as unsecure. Modern browsers don't really rely on the old common name anymore. They compare the URL strictly with the subject alternative names list. If users type intranet.contatoso.com, that exact DNS name must be present as a SAN entry, or you'll see a name mismatch warning. That's why you can't just reuse a generic certificate. Plan your DNS records and all required hostnames first. Then request a certificate whose SAN list matches them exactly. For IIS, 2 things must line up: purpose and proof of ownership. The certificate's EKU has to include server authentication, identified by the OID 1.3.6.1.5.5.7.3.1. That tells clients this certificate is valid for a web server. Then the private key must be present and accessible. During the TLS handshake, IIS uses that key to prove it actually owns the certificate. If there's no private key or the permissions are wrong, you won't be able to bind the certificate and connections will fail. When you design an IIS certificate, treat the template as your contract between servers and the CA. Start by duplicating the built-in web server template so you inherit sane defaults. Then verify it includes the server authentication EKU and appropriate key length and renewal settings. Next, decide how subject names are built, automatically from Active Directory or supplied manually for custom DNS names. Finally, lock down enrollment permissions to the specific server admins or server groups that actually need it. Once the template is published, the IIS server enrolls for a certificate using the local computer store. You can use the certificates console, certrec, or a PowerShell script. The tool doesn't matter as long as the request matches the template. Be sure to include all required DNS names so the SAN is correct. After issuance, confirm the certificate appears under Personal, has the expected SAN and EKUs, the right validity, and an associated private key. For IIS to see your HTTPS certificate, it has to live in the local computer personal store, not the current user store. If it's in the wrong place, it simply won't show up when you try to bind HTTPS. Also confirm the certificate includes its private key after import. Without it, IIS can't use the certificate. Finally, make sure any required intermediate CA certificates are installed and trusted using certlam.msc, PowerShell, or MMC to verify. Once the certificate is installed, IIS still needs to be told to use it. Think of the HTTPS binding as the rule that says, for this IP on port 443 and this host name, use this specific certificate. You'll choose HTTPS, confirm port 443, pick the correct IP, then select your ADCS certificate. If you're using host headers or SNI, enter the exact DNS name, then test the site in a browser. When a single IIS server hosts many HTTPS sites, host headers let them all share the same IP and port. The challenge is choosing the right certificate during the TLS handshake. With SNI, The browser includes the hostname in that handshake. IIS reads this name, matches it to a binding, and returns the certificate whose subject or SAN contains that hostname. Older clients without SNI support may need a fallback certificate or a dedicated IP. Now that the certificate is bound, verify the end-to-end experience from a domain-joined client. Browse using the exact DNS name listed in the certificate's subject alternative names. If the browser shows a secure lock with no warnings, open the certificate details. Confirm the chain builds to a trusted root, the certificate isn't expired, the issuer is correct, and the enhanced key usage includes server authentication. If any check fails, fix that component before moving on. When a browser connects with HTTPS, it runs a short series of checks before it trusts the connection. First, it builds the certificate chain and confirms each link leads to a trusted root. Then it verifies the certificate hasn't expired and that the hostname matches a SAN entry. Finally, it checks whether the certificate has been revoked using CRL or OCSP. Any failure in this pipeline becomes the browser warning user C. Most IIS certificate problems fall into a few patterns. If the certificate doesn't appear in IIS, it's usually in the wrong store or missing its private key. If the browser shows a name warning, the DNS name or SAN set is wrong, and the certificate must be reissued. Expired or untrusted chains are solved with renewal and proper CA installation. Treat certificates like assets. Document owners, map them to sites, and monitor expirations continuously. You've now taken IIS from plain HTTP to a properly trusted HTTPS service using ADCS. You planned certificate requirements, enrolled the certificate, bound it to the site, then verified TLS, chain health, and revocation. Next, you'll reuse this model for RDP, domain user and computer certificates, renewal, and recovery.